morning, all. It's a beautiful Friday morning here in sunny California. Less than a week until Christmas. Happy holidays, everyone. Merry Christmas. I hope you're doing well. This is Henry from ASM Tutoring, once again attempting to serve as your wise old sensei. Today we will discuss gravity and orbital period. So this picture, all right, I realize it's not great. I admit I used generative AI to generate this image, so it's not quite perfect. But the moon orbiting around the Earth, for example, it's basically falling in circular motion around the Earth. Gravity is holding it in the orbit. If there was no gravity, the moon would fly off into space. Gravity keeps it in orbit in a regular circular pattern. So how can we find the period of this orbit from what we know about gravity and circular motion? So let's visit our whiteboard. So we'll start off with something that all physics students learn right away. F equals ma. The net force on an object equals that object's mass times its acceleration. The moon is moving in a circular path around the Earth. Recall from circular motion that A equals v squared over r, where v is the linear speed of that object going round and round in a circle. F must be the force due to gravity. The gravitational force is capital G, the universal gravitational constant, times the masses of the two objects, capital M being the mass of the Earth. We will let little m be mass of the moon, all divided by r squared, the distance between the two objects, the moon and the Earth, the radius of the circle, effectively. This equals m times v squared over r, because a is v squared over r. Whoops. Let's try this again. V squared over r. You notice there's a little m on both sides. Those can divide out. Now, v squared in terms of angular speed, v equals omega r, where omega is the radian speed or radian frequency of the object going round and round in circles. So that means v squared over r equals omega squared r squared over r. And then this equals omega squared r, because r squared over r is just r. So now we have capital G, capital M over r squared. Whoops, that doesn't look right. R squared. Let's see if Henry can write properly today. Equals omega squared r. Now remember from cycles, cyclical wave patterns from learning about sine and cosine waves, omega also equals 2 pi over t, where t is the period. That means omega squared equals 4, because 2 squared is 4, pi squared over t squared. We will substitute this in for omega squared over here, which yields us g m over r squared equals 4 pi squared over t squared r. Let's move down a little bit. Let's see if I can move this down. Okay, good. Now, to simplify this, we can multiply everything by r squared t squared over gm. If we run the numbers, that will give us t squared over on the left equals 4 pi squared r cubed, r cubed over gm. So for a mass orbiting a planet, the orbital period does not depend at all on the mass of the satellite orbiting. It only depends on the radius, the gravitational constant, and the mass of the planet that is being orbited. That's it. And of course, if you want t itself, you could just square root both sides. But this equation is what you will commonly find in your physics textbook or lecture notes about orbital period of a satellite around a planet as a function of the mass and the radius. This has been a simple lesson in orbital mechanics, specifically how to find the period of an orbit if you know the mass of the planet, the gravitational constant, and the radius of that orbit. If you would like to learn more, I'm available for hire as a private tutor. Let's see if I can zoom here. All right. You can see my content information in red up at the top center of the whiteboard here. The first 1 hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service in helping you succeed. And as a thank you for watching all the way to the end of today's lesson, when you contact me, please mention the code FREEBOOK. And at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. This book is also available for purchase on the Barnes & Noble website. I wrote this book in an effort to provide advice and guidance to help students, and particularly high school students and college students, to succeed in school, in work, and in life. Thanks for watching. Have a good day, and Merry Christmas.